In this video, we are going to talk about the nomenclature of alkynes. Let's name the following alkynes. So let's consider this one. So we need to identify the parent chain in this case. And then the parent chain is, we're starting from here. So yes, carbon 1, carbon 2, carbon 3, carbon 4. So this is a butane. But we have two substituents, which are methyl groups. Now we need to start from the terminal carbon where the alkyne starts. And you see that this alkyne starts on this carbon number 1. This is 1 butane. So here is carbon number 3. So this is 3,3 dimethyl 1 butane. So 3,3 dimethyl. Let's come to this one. So with this, let's identify the parent chain 2 in this case. So starting from here, this carbon number 1, carbon number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9. So this is not 9, but then the functional group is on carbon number 2. So this is a 2, not 9. So we can fragment the molecule and name it. So we know we have a 2, not 9 in the name. Then apart from that, there are two substituents here, which is the iodine substituent, but they are on carbon number 6. So we have a 6,6 diiodo. Diiodo. Then apart from that, we also have this substituent here, which is a methyl substituent. And then this methyl substituent is on carbon number 7. So we have a 7 methyl substituent. And therefore, this molecule is going to be 6,6 diiodo, and then 7 methyl 2,9. So this is how the name is. Now the iodine comes before the methyl because I comes before M in terms of alphabetical order. And that's how come this is 6,6. It starts from the iodo. When considering the order of alphabet, the prefixes tri, tetra, mono, tris, all of that, you don't consider it. What you consider is the actual name of the substituent. Let's come to this case. So you see that this carbon number 1, let me number them, number 2, number 3, 4, 5, and 6. So 6 carbons, and 6 carbons, we are talking about a hexane. And so you can see that this is a 2 hexane. However, we have a substituent on carbon number 4. So we have the substituent is a methyl. So this is 4 methyl. And then we have the triple bond is on carbon number 2. So 2 hexane. So that is the name of that molecule. Let's come to this molecule. So we see that this is carbon 1, carbon 2. So 1, 2, 3, 4, 5, 6, 7, and then carbon 8. And then we have a methyl group, which is a substituent on carbon number 4. So we have a 4 methyl as a substituent. And then the triple bonds are 2. We have triple bond on carbon number 1 and triple bond on carbon number 5. So this is the case of a diene, and therefore the name is going to be 4 methyl. Then we have carbon number 1, so 1, 5. Then there are 8 carbons, so this is an oct. So octa diene. So the name is 4 methyl 1, 5 octadiene. Let's come to this case too. So let's identify the parent chain. Starting from here, it is 1, 2, 3, 4, 5, 6, 7, 8. This is also an octane. We have one triple bond. But what is on what substituent? On what carbon number is the triple bond? So one, let me number them 1, 2, 3, 4, 5, 6, 7, 8. Now, if we start in the reverse order, we will get the same thing. So it doesn't matter. So we see that the triple bond is on carbon number 4. So this is an a 4 octane. So we have 4 octane in the name. Then apart from the 4 octane, you see that there are these ethyl groups on carbon number 3 and carbon number 6, which are substituents. So we have a 3,6 di-ethyl. So let's combine the name. So this becomes 3,6 di-ethyl, then 4 octane. Now let's come to this one too. So this is carbon number 1, carbon number 2, number 3, number 4, and number 5. And then there is a bromo group and then a methyl group as substituent on carbon number 4. But B comes before M, and therefore this is going to be 4 bromo, then 4 methyl. Then we have 5 carbons. So since there are 5 carbons, but the triple bond is on carbon number 2, so it becomes 2 pentyne. Let's consider this. So the parent chain. Now in this molecule we have an alkene and we have an alkyne. The rule is that we need to start from the carbon that contains either the alkene or the alkyne, which gives the least number. So if we start from here, we will meet an alkyne, and this alkyne will give, okay, if we start from here, 1, 2, 3, 4, 5, 6, and then carbon number 7. So the alkyne is on carbon number 4. But if we start from here, 1, 2, 3, 4, 5, and 6, the alkene is on carbon number 1, and therefore this is the correct order of numbering. So now, so since there are 6, then we know that it is a hexane. So the name will end with an "-ine", but then this parent name will contain a hexane. And so now we have a methyl, which is on carbon number 7. Sorry, we have a methyl which is on carbon number 2 as a substituent, and therefore the name will start with 2-methyl. 2-methyl. Then the hexane double bond is on carbon number 1, so 1-hexane. But in this case, when spelling the hexane, instead of adding the last E, which makes it an alkene, you ignore that E. So it becomes, so if this was propene or even butene, then it will be butene like this. You won't add the last E. And then the triple bond is on carbon number 3, so it becomes 3-ine. So that is the name. The name is 2-methyl, 1-hexane, 3-ine. It's the same thing here. But now, in this case, you see that if we start from here, the alkyne is on carbon number 1. And if we start from here, the alkene is also on carbon number 1. So which one should we give precedence? The rule says that we should give precedence to the alkene over the alkyne. And therefore here will be 1, 2, 3, 4, 5, 6, and 7. So the alkyne is on carbon number 7 and the alkene is on carbon number 1. But remember that since it contains both alkene and alkyne, then the name will end with an I. But this is 7 carbons, so we are talking about heptane like this. So the name is going to be 1-heptane. Then the alkyne is on carbon number 7, so 7-ine. So this is the name, 1-heptane, 7-ine. Now, this molecule, if you look at it, you see that the alkyne is on, the alkyne is a substituent. This is a cyclohexane. So when the alkyne is a substituent, then we talk about the alkenyl. You name it as an alkenyl. So if it is 2 carbons, ethene, then that will be ethenyl. This will be the name. If it is 4 carbons, then it will be butenyl. 5 carbons, then pentynyl. So this is 2 carbons and therefore it's going to be ethenyl. Now we also have a bromine as a substituent. So let's try and then number the carbon. So carbon number 1, number 2, number 3, number 4, 5, and 6. So we are talking about cyclohexane. So 4 bromo, and then we have methyl on carbon number 1. So 4 bromo, 1 methyl, then 1 ethenyl, cyclohexane. So cyclohexane. Sorry, this name is wrong. Can you figure out what makes this name wrong? It is wrong because you see there is an E here and then there is an M here. Alphabetical order, E comes before M. So it's rather 4 bromo, then 1 ethenyl, and 1 methyl cyclohexane. So let's consider this molecule. If we start numbering from here, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 carbons. However, if we start from here, this will be, so the substituent, the alkene is on carbon number 5, and then the chlorine is on carbon number 8. If we start from here, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So you see that on this way, the alkene is on carbon number 4. 4 is better than 5. And therefore, this is a 2-chloro. So we have a 2-chloro. And we also have a 4-alkene. But then the parent name is a nonene. So 4-nonene. And then we have the alkenyl, and in this case it is the ethenyl on carbon number 5. So we have 5-ethenyl. It becomes 2-chloro, then 5-ethenyl, and we have the nonene, but it's on carbon number 4. So we have 4-nonene. Now let's name this last one. And you can see that this is an alcohol. The parent name, when you have an alkyne and you have an alcohol on a straight chain, precedence is given to the alcohol. So the alkyne becomes a substituent, so ethenyl. So it becomes number 1, number 2, number 3, number 4, yes, 5, and then 6. So we are talking about a hexanol, but it's on carbon number 2. Then we have 3,3 dimethyl, and then we have an ethynyl on carbon number 5. So the name becomes 5-ethynyl, and then 3,3 dimethyl, then 2-hexanol. So let's number the carbons. This is carbon number 1, carbon number 2, number 3, number 4, 5, 6, 7, 8, 9. So it contains a triple bond and then a double bond. Now, there is a certain difference I want you to notice here. The difference is that if both the alkene and alkyne are on a place where when you start you get the least number of carbons, then precedence is given to the alkene. But when the alkyne is on carbon number 1 and let's say alkene is on carbon number 7, then precedence is given to the alkyne. So that is the difference. So in this case, it is going to end with an ion, but this is a 1 ion. And then there are 9 carbons, so we are talking about a non-N. And then there is a methyl group on carbon number 4, so we have a 4-methyl. So at the end of the day, the name is going to be 4-methyl 7 non-N, then 1 ion.